force C. What? I have some. Yes. I have some somewhere. What? Alright, for C, if f of x equals 2, what is x? So we're given what? Our x or our y?
X.
Y. So if remember, if it gives you f of x equals something, it means it gives us y. So I'm trying to find x. So if that's the case, it says f of x is 2. So I'm going to say 2 equals x plus 2 over x minus 6. I'm going to multiply by the denominator. Or, well, yeah, that's the same thing. They work. I was going to say make it a proportion, but it's the same thing.
I did 0 equals whatever.
So I'm going to have 2 times x minus 6 equals x plus 2. What do we have to do now? Distribute. So 2 times x, 2 times negative 6, and then we get x plus 2. If I subtract x from both sides, I get x minus 12 equals 2. So what does x equal?
How does the x minus 6 get over there?
Oh, multiply this by both sides. And then you said D? Alright, D, we're looking for x-intercepts. So if we want the x-intercepts, does x equal 0 or y equal 0? Y. So I'm going to set the same thing. I'm going to do the same thing except 0 equals x plus 2 over x minus 6. And I'm going to solve for x. I'm going to start the same way. Multiply both sides by x minus 6. So I'm going to get 0 equals x plus 2. And x equals negative 2. Any other questions? The rest of the homework was pretty good? Alright, let's start on the notes. Alright, ready? Some of y'all taking the ACT on Saturday? I am. Yes, you are. Alright, we'll see how this goes. We may do some ACT stuff at the end. We may just go on. Yeah, we'll probably do something. That'll help people that are taking it.
It is. It'd be fun taking that after the football game done. Yeah.
That's true. You'll get home at like 10
So I
o'clock.
thought I'd get home later after home game before we go somewhere.
Yeah. Alright, here we go. So today we're kind of piggybacking off of what we did yesterday, learning more about graphs. And so now we're going to add this increasing, decreasing constant. Alright, so increasing. That's just if the y values are increasing as you go from left to right. So you always start on the left side of the graph. If I follow my graph and my finger and my pencil goes up, it's increasing. If it goes down, it's decreasing. If it stays the same, it's constant. So for this first one, I'll use pink. Sorry, pink. It's increasing on an interval if the y value increases. See how we use the same word there? It's just what you think it is. And so on this graph to the left, let's see where it's increasing. It's increasing here. Let's increase here. And it's increasing there. Right? It's just wherever the graph is going up. So we would write that, what is that, from negative infinity to what point? 1, 2, 3, 4, 5, 6, 7. So we would say this is increasing from negative infinity to negative 7. Union, and then this piece here from 2 to 4. And then 7 to 9. Remember, it's not, you don't put the hard brackets because at the points where it's going from increasing to decreasing, that point is doing neither one of those. Alright? For decreasing, I'll use green. So again, if it's decreasing, then our graph decreases or goes down. And so that would be these two places. Here and here. What's the interval of the one on the left? Yeah, I wrote the first one wrong. I thought it was the 7. It should be like 6.5 or something. So I'll change that on the notes up here. But yeah, negative 6.5. To what? Negative 5. What's the other one? Seven. All right, is everybody seeing where we get those numbers?
I got 10.
Hmm?
I got 10.
You got 10?
Yes.
So it starts here. Whoops. So it starts here. It ends, well, on this one. So 1, 2, 3, 4, 5, 6, 7. Alright, I'm going to go back and change this one while I'm thinking of it. I wrote that completely wrong. That should be negative infinity to negative 6.5. And I know y'all can't do that. Alright, and then the last one, if it's constant, the y value stays the same. The same. so that's this piece here in the middle. Alright, so that would be whatever the other piece that we don't have. -5 to 2. Alright, y'all good with that? That's not too bad. Now, the local or relative extremum. Alright, so a local max or a local minimum. So local extremum, it's just the relative height or highest point and lowest point. So like a local maximum is at some point if the y value at that point is the highest interval around that. So it's not saying the highest point for the whole graph or the lowest point for the whole graph. If it's like a mountaintop or a peak in the graph, it's a local maximum. If it's like a valley, it's a local minimum. So it's just saying, and I'll write this here first, but if we have a local maximum, then f of c is greater than f of x for an interval around c. So that's saying we pick a point, and the y value at c is bigger than the other x value or other y values close to it. So if we come over here and look at this, how many local maximums do you think we'll have? 2. We have this point here and this point here because it's the highest y value around a certain set of points. Now if we picked this point, it wouldn't work, right? Because no matter what interval we pick, when we pick this and that, there's still an x value or a y value above it. Same thing here. We can still get really close to it and make that interval really small, but there's still some y value that's bigger than that. So that's why we picked the mountaintops, the peaks. It's because no matter how, if we pick this point, no matter how small the interval we make it, it's still the highest y value, isn't it?
I have a question. What happens if you get a point that's in the middle of both of them?
So,
Like in the middle of both of those. Like on the flat part, where you get a point
like this
there.
point here,
You had to find the relative maximums and all that. What would you do?
and it just showed you like this part of the graph.
Well, no. Oh, well, no, never mind. I see it.
Did have to shrink the graph down. All right, so we would say this point here. I don't know if you can. I'll just do this. Point here, and this point here. So that would be the point -6.55 and 4.8. Those are our local maximum. Local minimum, same thing, except now around that interval.
May I have attention, please? At this time, students in Rita Hood's homeroom, Miss Noble's homeroom, and Coach Romine's homeroom report to the gym for pictures.
Now it's the same thing except flipped. So if we can create an interval where our point is the lowest around that interval. So how many do we have here?
1.
We only have 1. We only have this point here because no matter what interval we create, it's going to be the lowest point. Now we did these earlier. They might tempt you into being a local minimum, but they're not because it's just straight. So even if I create an interval there, that's not the lowest point. You could technically say any of these points are the lowest point. So our only local minimum is over there at 7, negative 2. And as that note points out, it only happens when we're transitioning between an increasing and decreasing point in our graph. We good with increase and decrease in local maximum, local minimum? Not too bad. All right, even and odd. The rest of the time, this is the last new thing that we can learn from just looking at a graph. Whether a function is even or odd. Now, an even function, they're functions that are symmetric with respect to the y-axis. Alright, so if we look at all three of these graphs, when it says they're symmetric with respect to the y-axis, that means if I draw a dotted line, and I were to take both sides of these and fold it over on the other, they'd match up. That's what it means to have symmetry with the y-axis. So I take one side, fold it over, and it should lay flat and overlap the other side. That's even, if you're just looking at it. That's how you tell if it's even by looking at the graph. If you want to tell if it's even algebraically, so if you have the equation of the function, I would take negative x and plug it into that function. What you get out would be the exact same thing. You would get out f of x. We'll do some examples at the end, but essentially, you have your function, whatever your graph is. If I plug negative x in and get my original function out, then it's even. That's what this says. Odd is similar, slightly different. Odd functions are symmetric with respect to the origin. And you'll hear me say something like they have rotational symmetry. So to be odd, they're symmetric around the origin, with respect to the origin, or they have rotational symmetry. So this means it's like I take a pin and stick it in the origin. Then I can take my graph and I can rotate it half a turn and it lays flat on it. So if I took this and rotated it half a turn, it'd end up in the same spot, right? That's what this means. I take it, I rotate it half a turn, and it ends up in the same spot, or a full turn. Either one has rotational symmetry, or symmetry about the origin. Now, algebraically, when we plug this in, we still take our negative x, same thing we plugged into the even functions. I plug it into my function. If I get out negative f of x, so if I get this out, then it's odd. So essentially, if I plug in negative x, and what it does is it changes, for the most part, changes all the signs, then it's odd. No, negative, this is what it's this. That's how you write it. Alright. do we get the graphing part? I feel like the graphing is a little easier than the algebraic one. We're good with the graphing? All right, so let's do a couple of examples. This kind of puts everything together. All right, so if I'm looking here, I want to do this thing. All right, so I'm going to freeze this so we can just keep this up here to reference. All right. X-intercepts. Do we have any? What are they? -1 and 1. So I just put the x values there. -1 and 1. Do we have any y-intercepts? 2. All right. The domain. Does this function keep going on forever in either direction? No. What's the smallest x value? -3. What's the largest? 3. They both have hard brackets. And I'll unfreeze this in a second to show you how we're running. All right, what about the range? Same thing. They don't go off to infinity. What's the smallest y value? 0 with a hard bracket. What's the largest y value? 3. All right, so there's how we write those. Both have hard brackets because both of them are included. All right, C is talking about increasing, decreasing constant. So, increasing, decreasing constant. How many places are increasing on this graph? 2. So if they're increasing, I'm going to try to keep them the same here. All right. The first one that we're increasing is increasing from where to where? Good. -1 to 0. The second one's increasing from where to where? 1 to 3. So, -1 to 0, 1 to 3. What about decreasing? -3 to -1. And what? 0 to 1.
You said 0 to 1?
0 to 1. So this is how you would write those two. Remember, you put that U in the middle if we have more than one interval that matches this thing. Matches whatever you're increasing, decreasing, or whether you're staying constant. Do we have anywhere where it's constant in this graph? No, we don't. So, I think that's blue over here for me. Yes. So, I'll just draw that. Or you could say none. Alright, what's this orange and red? Alright, local maximum. Alright, you said -3, 3. What else? 0, 2, good. 3, 3. Now, I'm going to change 2 of those. Endpoints can't be local min and max. Because technically, if you make an interval here, there's nothing to compare it to on the outside. Make sense? So, your endpoints can't be local min and max. only because there's nothing in reference them on one side. So the only one that we're going to have is 0, 2. Then what about minimums?
Negative 1, 0.
Good. Negative 1, 0, 1, 0. Negative 1, 0, 1, 0. Why don't we need the union symbol there? Oh, we're talking about an interval here? No, we're just talking about points. So you just list them like you would list anything else. It's not a set of numbers, it is a single point. Now, is this odd, even, or neither? Even. Why is it even? If you fold it over the y-axis, they're symmetric. So it's even. All right, let's look at the next one. All right, x-intercepts, do we have any? 1, at.
May I have your attention, please? At this time, students in Ms. Vice's homeroom, Coach Williams' homeroom, and Coach Cooper's homeroom report to the gym for pictures.
Where's our x-intercept? 1.
I think you said very. I love you. He was also, if you listen to him, I tell you, he did not he did not get on to any, he didn't get on to even talk or anything. If you listen to it though, you would learn.
All right. Come on.
I learned something from
Do we have any y-intercepts? No. Now, look. At some point, this might intersect. We're not sure. It does not on the graph. It does not tell you like it does here. So, if this were to do this on homework or a test, you do the same thing. Unless you can see what the actual point is where it's crossing, you would say no. All right? There is a point. What about the domain? For this, let's pretend that it does not cross that. All right? Let's pretend it does not cross the y-axis.
Or is the Y?
Yeah, so let's pretend it does not cross the y-axis. Since it's not clear, let's just say it doesn't. So what would that make our domain? 0 to infinity. Positive infinity, yes. What about the range? Now, even though it doesn't cross the y-axis, it's still got the arrow, so it means it's going down forever. So what's that mean our smallest y value is? Negative infinity to what? Positive infinity. No, sorry. No. What's the highest it gets?
That was like
I'm going to go with, that's 1 and say 1/2. 1.5. Not 1/2. 1.5. So, no, it's a soft bracket. Because it never, since it's an asymptote, it will never get to this line, it will never touch it, it will never cross it. So it'll get as close as you can get, yep. It'll get to 1.49 repeating. So it'll get really close to it, it won't get it.
When are we gonna start doing
What?
those? When are we gonna start like calculating
Once we start doing rational functions. It's towards, if I remember right, it's towards the end of the year. Because I think I did it here last year. All right, we're back to increasing. So where does this increase? The whole thing's increasing, right? It never changes? The whole, it's always increasing, right? If I start from left to right,
Yeah, I thought that you said never changes. That's what I thought.
oh, sorry, yeah. It never changes, so it's always increasing. It never changes to constant, never changes to decreasing. So this is the same as our domain. 0 to infinity. All right, then that means it's not decreasing ever, not constant ever. Do we have a local maximum? No. Do we have a local minimum? Nope. Is this even, odd, or neither? All right, it's neither. Good. Because if I were to stick a pin here and I spun it halfway around, I'd have one graph here, but I wouldn't have one here, right? So it's neither, and then it doesn't flip across. So this is neither. All right, y'all do the third one. Y'all do the third one. What?
-2.33.
Oh,
Negative 2.3.
sorry. That's a little off.
I'll say that time it actually gives it to you, so there's no estimate on that one.
May I have your attention, please? At this time, seniors, last name G through M, report to the gym for senior portraits. Also, 10th grade students in Ms. Frazier's homeroom, Coach Briggs, and Mr. Howard's homeroom report to the gym. That's Frazier, Briggs, and Howard homerooms.
I hope I look pretty.
Do we have
Yes.
Yes, you have to go. No, she loves this class so much.
Oh,
Next, if I miss this class, I literally.
so did you take a break on this?
I need to.
I'm gonna go apply all my makeup. Oh, yeah, I can't.
I forgot today's picture day.
Texas.
Not a good morning.
I walk outside, swap my hat from. My tire was flat.
Yeah, not a good morning.
Yeah, and then my stepdad's leaving to go on a business trip. So he's like stressing, and I said, will you please fix my tires? He's like, I can't fix my tires.
Afterwards. All right. Why intercept? One. Good. All right, guys. Hey, refocus. We've got this, and then we're going to do a couple more examples, and we're going to work on some ACT stuff. All right. Domain. Good. -3 to 3. What about the range? Good. All right, now we've got increasing. How many places does it increase? 2. Did you count this as 2 pieces?
Yes.
Okay. Since it doesn't change from increasing to constant or increasing to decreasing, just keep it as one long thing. Because really, the only reason this point's here is because it crosses the x-axis. So let's see, that's from -3 to -2. And from 0 to 2.
Yeah, it's pretty cold.
It's kind of chilly in here. Once we get done with this example, all right, decreasing.
2, 3.
Good. This last little bit here. Two to 3. And then is it constant anywhere?
2 to 0.
Negative 2. All right, local maximum. 2, 2. What about local minimum?
I put -3, It's not that wrong. Or do you have to American it?
Correct. Yep, there aren't any on this one because there are none here because the 2 endpoints you don't have anything to compare them with, and then this point here is coming from a constant. So really, if you made an interval here, it's not the lowest point. So there are none in this one. Even, odd, or neither? Good, it's neither. All right, so there's all 3 of those. Oh, I should have put this note back. I thought we were going to have one. All right, we're going to do 2 of these. Hopefully we'll get the hang of it. If not, we can do a 3rd. All right, so now the last thing we're going to do is we're going to talk about whether we can find out whether it's even, odd, or neither algebraic. So I put some on the back of y'all's worksheets tonight. I thought we'd have time to do that. Save these for Friday. We'll do that on Friday. You will need a piece of paper for this unless you can write really small. I apologize. The stuff on the back we'll do Friday. All right? We'll do ACT stuff to help out a couple of y'all that are taking it Saturday. And really all of y'all for next week. So you take that, we'll do that Friday. It's helping y'all work with the calculators.
Those are hard to figure out on their own.
They are. That's why we're going to go through it. So we're doing, now, you may need an extra sheet of paper, but the problems we're doing are on that. Before you put it up there. At the very bottom. Alright, so I want to determine if these are even, odd, or neither just by given the function. So I'm given f of x cubed minus x plus 2. Alright, so for it to be even, remember, even, we need f of negative x to equal our original function that I just wrote down. So that means I'm going to take negative x and plug it in here and here. So I'll get negative x cubed minus negative x plus 2. So that's going to be negative x cubed, right? Plus x plus 2. Is that the same thing as our original function? No, so it's not even. Alright, now let's check to see if it's odd. Which means we need f of negative x to equal what? Good, negative f of x. Do you need to do any work for that left side? Why not? Do we need to do any work to see what this is? Don't do it. It's right here. We just did it. So just bring this over. So I'll have negative x cubed plus x plus 2. Now, if we want to do negative f of x, that means I take this whole thing and change the signs. So this would be negative x cubed plus x plus, or sorry, minus 2. So negative x cubed plus x minus 2. Are those the same thing? No. So not odd. Therefore it's neither. All right. You didn't have to?
No, I have that over the summer.
Questions there? Feel pretty confident after seeing the first one? All right, let's look at 2. We're doing the same thing. I always start with even, go to odd, and then if they're neither one, it's neither. So we want f of x equals x cubed minus x. And I'm going to rewrite this stuff just so we remember it. You don't have to write it every time if you are confident in it. So we want f of negative x to equal our original function. So I'm going to plug in f of negative x. So I'll get negative x cubed minus negative x. That's going to be negative x cubed plus x. Is that our original function? Nope, so it's not even. Alright, what about odd? We want that same f of negative x equal negative f of x. Where did I get that negative x cubed plus x? Just brought it over. Now, if I take negative f of x, I'm changing these two signs, right? So it'll be negative x cubed plus x. It's the same thing, isn't it? So this one is odd. Y'all get the gist? You want to see one more?
May I have your attention, please? At this time, 10th grade students in Mr. McGee's homeroom, Mr. Melton's, and Miss Penley's homeroom report to the gym for pictures. That's McGee, Melton, and Penley's homeroom.
If you change the sign, wouldn't it be positive x cubed plus x? Or negative x?
Because we're just taking this, it's already positive here.
Okay.
So we're just taking it and sticking a negative sign out front. The next one I was going to show you just turns out to be even. Y'all want to see it? Just to see it? Or y'all feel good? Alright. Your homework is 1 through 11 odd.
Is it on the back?
It is, no, it's not on the back. The stuff on the back is what we're going to do Friday. It's learning how to see this stuff on a calculator, with tables, with looking at the graph, plugging it down. It is on the back of this homework.
1-3.
It is the 1-3 homework on the top, on the left. 1-3 part 1, 1 through 9 odd.
1 through 9 or 1 through 11?
Sorry, 1 through 11.